Arvis, welcome to Arvis Mathematics channel. In this episode, we are going to look at some applications of binomial expansion. Without further ado, let's look at the following example. Alright, let's get started now. So one of the application of binomial theorem or binomial expansion is to let us to estimate the power of a decimal number, right? So let's look at the first question here. The question asks us, without using calculator, find the value of 1.002 to the power of 10 correct to 5 decimal places. Alright, so to tackle this question, we must know the binomial expansion. Alright, so let's start now. So we have 1.002 to the power of 10. Okay, so first of all, we can let this one 1 plus x to the power of 10. Okay, so we make 1.002 become 1 plus x to the power of 10. Right, so now we may apply the binomial expansion now. So based on the binomial expansion, the first term 1, just copy here, so it's 1 power 10, right? Then plus, then we take the power 10 C1, right? Then next one will follow by 1. Okay, here the power here we should take 10 minus 1, right? So 10 minus 1 is 9. Then followed by the next term, which is positive x. Okay, so we may write it as x to the power of 1. Okay, so I need you to bear in mind that 9 plus 1 will give us 10. Okay, so which is the power 10 here, right? So next is followed by 10c2, right? Then 1. Okay, the power here we take 10 minus 2, right, which is 8. Then next one followed by x. Okay, here we should make it to power 10, right? So hence the x here is 2 because 8 plus 2 is 10. Alright, so we can expand the first 3 terms, right? So we just write the first 3 terms we'll do, then the back just followed by plus triple dot there. Right, so next part we may simplify the term now. So 1 power 10 is 1. Okay, here is plus. Alright, so 10c1 here, 10c1 I need you all to know one concept that is nc1 is n, right? So hence 10c1 is 10. Okay, so here we have 10 times 1 is 10, right? So here we get 10x, then plus 10c2, right? So 10c2, nc2, the formula will be, actually is n minus 1 over 2 factorial. Okay, so this exclamation mark we call it as factorial. So 2 factorial means 2 times 1, yeah? So hence we may put in the value 10c2. So here 10c2 is equals to 10 minus 1 is 9, right? So 9 over 2 factorial, as I mentioned just now. 2 factorial is 2, right? So we can cut the 2 and 10 here, we can get 5. So 5 times 9 will give us 45, right? 45 times 1 will give us 45 as well. So we have 45x squared, right? And plus dot dot dot. Okay, so next part. Okay, we may find the value of x. Then once we found the value of x, we can put it inside our expansion, right? So what value of x we can use? Actually, we can get a hint from here. 1.002 and 1 plus x. So we make them the same. 1 plus x equals 1.002. So hence our x will be 0.002, right? So once we got this, then we may substitute this value inside our expansion, right? So based on our expansion just now, we get 1 plus 10x plus 45x squared, right? Just now here. Okay, so hence we put the value of x 0.002 inside the expansion. 1 plus 10 bracket 0.002 plus 45 0.002 square. Okay, so next part we may do it manually for this part. Okay, let's get started now. So here we have 1 plus 10 times 0.002. We can move the decimal 1 place to the right, so it will give us 0.02 plus 45, right? So this part 0.002 we can make it as fraction, which is 2 over 1000, because there are 3 decimal places, so we have 1000 at the bottom, right? So we have followed by the square here. Next, 1 plus 0.02 plus 45. So here 2 square is 4 over 1000 square will give us 1 million, right? 6 zeros at the back.
Okay, so next part, 1 plus 0.02 plus 45 times 4 will give us 180, right? 180 over 1 million. And this part will give us 1 plus 0.02 plus 0.00018, yeah? We have 6 zeros, right? So final step is we add them up. So hence we get 1.02018. And this is our final answer, correct to 5 decimal places, right? So you may use the calculator to check the answer. So just type 1.002 to the power of 10. Let's see whether you can get 1.02018 as your final answer. Alright, so next part, let's look at the second question here. So what if we have 2.995 to the power of 4? And if let's say we use back the same concept just now, we start from 1 plus x to the power of 4, right? Then our x will be so big, right? So can you just try to imagine that we make it become 1 plus x equals to 2.995, and our x will be 1.995, right? So if you use this value, then it's very difficult for us to calculate the answer, right? So hence, instead of using plus, we may use minus. So how do we use minus here? Actually, we can think of the bigger number here, which is 3, right? We can take 3 minus x to the power of 4. Okay, so let's get started to expand this expansion. So now 3 power 4 plus 4c1, here 3, then 4 minus 1 is 3, right? Then the next term, which is the right term here, negative x, okay? So negative x power 1, okay, because we need to get power 4. So 3 plus 1 will give us 4, right? Okay, next part, actually we can follow it by 4c2, then 3 power 4 minus 2 is 2, then negative x power 2. And we may expand the first 3 terms we'll do. So the rest we can put it as plus dot dot dot. Alright, so next we can simplify further. So 3 power 4 will give us 81, right? So if you are good, then you can memorize the value. 3 power 4 is 81. Then here plus minus is minus. 4c1 same goes to here. So 4c1 is 4. 3 cube is 27. So if we times that together, will give us 108, right? 108x. Then here negative square is positive, right? So we just give us positive. So here will become positive. Next 4c2 just now, based on the formula, 4c2 is 4, then 4 minus 1, right? So it's 3 over 2 factorial, so which is 2. Then we can cut this 2. So 2 times 3 will give us 6. So this is 6. And 3 squared is 9, right? So 6 times 9 will give us 54. 54x squared, and so on, right? So next, we can just equal this 3 minus x with 2.995. 3 minus x equals 2.995. So hence our x will be, how much is it? It's 0.005, right? Okay, next we may put it into the equation. So we have 81 minus 108, 0.005 plus 54, 0.005 square, right? So hence we have this 81 minus 108. This one we can change to 5 over 1000, right? Plus 54. Then here is 5 over 1000 square, which will give us 25 over 1 million, right? And actually, if you can do it fast, then our final answer will become 80.46135, okay, which is correct to 5 decimal places. Okay, so far so good, yeah? Okay, so let's move on to the next part. So actually I've prepared some questions to let you all to practice. As we know, practice makes perfect, yeah? So here are the 3 questions. So just evaluate this without using calculator and correct to 5 decimal places. Alright, so happy trying and all the best.
Here comes to the end of this episode. If you like this video, like it, share it among your friends, and most importantly is subscribe to our channel so that you won't miss any of our upcoming videos. I will see you on next episode. See you soon. Thank you.